Hello, everyone. Welcome to the fifth tutorial for Introductory Statistics for Social Sciences, ECON 1310. Today, we'll be talking about normal distribution. And today marks the point where we're moving from descriptive statistics towards inference statistics. And the normal distribution is probably the most used distribution in that sense, but let's continue with it. Before we start with our tutorial, one very important thing that some of you might have heard me discussing before is that your LBRT, the first one, is open, and the first attempt for the first one. So started this morning at 9 a.m. and will be open until tomorrow at 4 p.m. This is worth, the first LBRT is worth 20% of your total grade. So it's quite relevant to do. And there will be also a second attempt that open, second attempt, where is it? First attempt, optional second attempt that will be open at 9 a.m. on Thursday. So in 2 days, until 4 p.m. on Friday, in 3 days. So it's not too far from now. The LBRT also, it's a little bit different from the CML. It will be one question, it will be question by question. You have only 90 minutes, so 1 hour and a half to solve it. And it starts counting when you open your first attempt. Even if you have to close something, questions will be saved automatically. And by the end of 1.5 hours, the end of the 90 minutes, it will be submitted automatically. It's good to try to do it all at once, but if by any chance something happens to your computer, you lose your internet, you try to come back. If something really gets in the way for you to finish it, take some pictures, try to print screen or whatever evidence you can. But there will be a second attempt in a few days, in 2 days. And try to get the best. We will consider only the best out of the two. So it's worth trying both of them, right? Any question regarding LBRT 1? I'll check chats. Perfect. Okay. Will questions be similar to CML quiz? So a little bit different. Does this cover all content in confidence intervals? It will cover just the content from lecture 1 to 4. So it's the same content that we had for CML 1 plus CML 2, Harry. So just the first 4 lectures. And no worries. And how many questions? Oh, I thought I saw it somewhere. 90 minutes. Is it 10? Let me see if I can find how many questions it is. Quite an important question. You will have right when you open it, that it will be written there. But I don't know if it's a fixed number for all LBRTs. Maybe I can create a new ECON1310. Let's see if we can find. Can you guys? I hope you guys can see my screen, right? I'm sharing everything, I think. Course profile, semester. LBRT 1. Lectures 1 to 4. So it's not a fixed number of questions, as you can see. Let me see. Let's go back here, assessment. Let's see what it shows. I think I have I can see a little bit too many things now. Let's look like as a student. Semester 3, LBRT 1. First attempt. 12 questions. There we go. Here you can check how many questions it will be. I won't promise you it will be the same amount every time. But this is how you check how many questions we have. Okay. Let me check chats. No worries. Oh, perfect. Oh, yeah, sorry, I should have paid attention. It was in the chat. Thank you so much. Thank you for answering it. Any other question regarding LBIT?
Yeah, Francisco,
Sure.
can we go over binomial distribution, the graphs? Are we gonna have to deal with graphs that are in the, you know, the Tude 4 answers, the extra questions?
No, makes sense, Alex. Look, today, given what we have for the tutorial, it probably take the whole time, but definitely let me see if we still have what other option of consultation we have. Let me see if there's still one before the end of first attempt. I'll suggest, Alex, you can still attend Peter's consultation tomorrow.
Okay.
But it will be a tight thing. Well, no, you can, okay. So you would need to start maximum your LBRT at 2:30. So you have 1.5 hours before the end. So yeah, unfortunately, this will be like the next consultation prior to LBRT. But yeah, make sure you watch the recorded videos, Alex. Yeah, but apologies that I don't think I will be able to fit today a whole explanation. What we can do, let's see how it goes to the end of the tutorial, and maybe you can talk after the tutorial. How does that sound?
Yeah, that's what I was suggesting. Yeah.
Ah, perfect. Excellent. Amazing. So, all right. Okay. Let's go from here. So today will be the tutorial 5. We'll be talking about normal distribution, and what we want to the objectives we have for today is describe the characteristics of the normal distribution and standardized normal distribution. Interpret and use the standardized normal distribution tables and compute z-scores and associated probabilities, right? Let's go to the first question. And I will right away put on our first poll for this one while it's launching. Feel free to do. So I will read the question with you while the poll is open. A large city transit association has reported that the average revenue per passenger trip during a given year was $3.38, 3.38. If we assume a normal distribution and a standard deviation of 0.42 or 42 cents, what is the probability that the revenue per trip is? So for this first question, it will give us the chance of getting used to the normal distribution, particularly the standard normal distribution or standardized normal distribution. The poll that I launched will be asking you, what symbol would you give to the value of $3.38? The second question is, what symbol would you give to the value of 42 cents? And then I put out this little, have a look at this part of the screen here. So it's the same as we have in the for the first part of this course. And finally, the last question is, what's our variable of interest? So I have 6 answers up to now. How many people are we? We're 25, so still a lot of people to answer. Let's go, guys. 8, 9. So what symbol would you give? Look, a large city transit association has reported the average revenue per passenger trip during a given year was 3.38. So if we assume a normal distribution and a standard deviation of 42 cents, what is the probability that the revenue per trip is. And then we will do the rest. I have 15 answers. Consider I am one of the people. We still have 9 people to give it a go. Anybody else? Maybe another 10 seconds. 16, just missing 8. No. Oops, sorry. As per usual, I scrolled a little bit more than I should. And that's it. I'll win the poll. Amazing. 17 answers. And look at that. Now I will click here once again, and I highlighted a few things. So the Allied City Transit share results, so you can see. Association has reported that the average revenue per passenger trip during a given year was 3.38. So the average was 3.38. The first thing we need to notice here, despite we're not using the other side of the table, I think I'm giving out too much right now, but Allied City Transit has reported during a given year. You guys will see in the not only this week, but in the following tutorials that it sounds more like a historic data. So this is what usually happens. It's not a data set. It's not our sample. It's more like that's what happens. Like this is usually the population thing that we're talking about. If we said, oh, we had a sample of 13 and the average of those 13 was something, then we will be probably talking about the sample mean. But in this case, has reported during a given year, we're talking about population, right? So the average is 3.38. So it is mu. So congratulations, everybody. Almost half of the people got it right. Then the standard deviation 0.42, and we had sigma for 10 out of 17 people. Excellent, more than half of the people. And finally, what is our variable of interest? It's the revenue per trip. And it's exactly what they ask in the end here. What is the probability that the revenue per trip is? I notice I feel like normal distribution. We're talking about normal distribution, but it's not exactly the variable of interest. Normal distribution is more the distribution of interest, if we can say. Standard deviation, it's not our variable of interest. So, and it neither is sample mean, nor is the number of passengers, but the revenue of the trip that we're talking about. The standard deviation, it's given already, and the mean is given. I put sample mean was just to make it a little bit more difficult, but that's how we work. So the variable of interest, the things we need trying to find are the revenue per trip. Well, thank you so much for the ones who answered. I'll stop here. And look how we wrote. So we have mu 3.38, sigma 0.42. And our question for A, we're talking about what is the probability that revenue per trip is less than 3? So P, we're going to call our X, which is our revenue per trip. We're calling X smaller than 3. Let me click once again. Let's see what comes after. So you will see, we will do it a few times today. We're talking about the seagull distribution. You will see this little symbol we have in the corner of the screen. And here is a standard, it's like, it's a normal distribution. So we'll call it bell-shaped. Looks like a bell. It's a very flat bell, I would say. But we will do this for pretty much every exercise. And this is really important. It's really important to know how to solve exercises using this. Okay, so let's go. First, less than 3. We know that our mu, or our center, is 3.38. So when we're talking about 3, it's probably to the left of our distribution, right? If it was more than 3.38, it will be to the right. And then we ask less than 3. So we're probably talking about this proportion or probability that sits in this area to the left of 3. If you want to like, one thing that I saw other people doing was to do like, this is a little bit of an error. So it's the chance that x is smaller than 3. So it will be to the left. But that only works when x is on the left side. So you have a little error there. Let me clear. Okay. So let me close this one. How do we calculate this? I will click a little. We're going to make a Z transformation. And this Z transformation will be doing, so we're using, this is a standard normal distribution. So what does the standard normal distribution does? It brings this center mu, it brings it to 0. Let me see if I can, let me use a little bit of indication here, stamp spotlight. This one, is that what I want? Probably not. Nope. All right, I'll draw and erase. And it worked. So it will bring this guy to 0. And it does it very simply by subtracting. We had x, we had mu. Sorry, we're moving the center, so we subtract mu. So subtracting 3.38 from whatever number we have becomes 0. And it also transforms our standard deviation, which, for example, here, our standard deviation was 0.42. It transforms it to 1. So the number we have on top will be divided by the 0.42 to become 1. So now I don't want to vanish anymore. Standard normal distribution, in other places, you might see as an N with a 0 mean. Oh, sorry, it's vanishing. And stop doing that. Sorry, draw here, and with 0 mean and 1 standard deviation. It's a lot of names that I'm using here, but this is what is happening. And before we had a 3.38 with 0.42, and it's assumed it's a normal distribution. So we're moving this and this, and the way that we do that is through this formula here. Okay, so I'll clear all drawings and let's go. So Z transformation, we put the x is going to become a 0, a z. So we replace our x by 3 here. We replace our mu by 3.38. And we replace this sigma by 0.42, the standard deviation. The number that we get, if we put this in a calculator, will be 3 minus 3.38 divided, let me see if I can close. No, let me 3 minus 3.38. So first, minus 0.38 divided by 0.42, 90. And 0.90, here we're rounding it down to just 2 digits in order to look, so we can look in the table, right? Now that we say, what is the probability of this standard normal distribution to happen? So what is it, the probability that z is smaller than minus 0.90? And then we go to this table here, and I think you had a chance, and we will use it for every exercise today, and you guys will use it a lot during the tutorial. So this is very important. And this is like areas for the standard normal distribution. You will notice that we don't have negative. But the good thing about our table is that it measures the distance from the mean to the Z value that we want here. Let me be back with our drawing stuff. So from 0 to Z, but it's the same value because it's symmetric. Our normal distribution centered, it goes the same way both sides. So minus 0.9 is the same as 0.9 positive, right? I want you guys, so how do we locate? If some of you already know, perfect, Harry, convert to a Z-score on chat. Can you please add the value on chat? Like, and I don't want just one answer. As much as you guys can, please have it a go. Try to locate the 0.90 in this table and type down in chat. And in the meantime, if you don't have this table yet, I will show you how to get it from our thing here, from our website, Learn UQ, right? You can come to Learning Resources. Let me see if we have something available right away. No, but inside of Lecture 5, the normal distribution, if I click there, look who's here, Z table 8.5, page 768, third edition, blah, blah, blah. You can click, it will open. Make sure you save somewhere you can open easily, or like the first page for this course, because you're going to use it a lot. And it's very important, use this table. Don't use a different one, or Excel or other formulas, because for CMLs and LBRTs, there is a chance that there will be small differences in the digit. It's like in the decimals that might give you a wrong answer instead of the right one. So we assume for all the answers that you're using exactly the numbers in this table. Yeah. Any question up to here? Cool. So this is how you download it. For people watching at home, that's how you find. Let me see the chat. How well? Oh, great. Thank you for putting it up there. Congrats. That's the right value. One thing to pay attention here, let's use the values between 0 and 1 only. Let's not use the percentage, because this, depending on how you handle it, it might lead you to the wrong answer. Usually when we're talking about probability or proportion, somewhere between 0 and 1. So the 0.3159, it would be the best way of finding it. And how do we find? If you didn't know yet, you go to 0.9. And what is the second decimal after the 9? Was another 0? It's here, 0.3159. If it was a different one, we would look at a different column. So let's go back. And remember, one important thing, if you forget it's an area. And where this area is, this is the distance between the mean and the little Z value that we have. So there is this small thing here reminding us in a table how to use the numbers that we found. Let me clear, and let's go. So now that we know that it's the distance, let's go again, spotlight. It's actually this distance that we have. How much is this one here? On the area that is painted in red, right? We know that a whole probability, where's my mouse? Oops. The whole probability is 1. So half of it is 0.5, right? So if this other half is 0.5, it's pretty difficult to draw with a mouse, to write with a mouse. How can I find this one? And let's go. I'll just click once again. We just subtract from 0.5. We take the 0.3159 that we had there, and then we have 0.1841, which is our answer. Let me have here. Amazing. Thank you very much for your answers here in chat. And that's it for part A. Any question? No. Feel free to, if you guys feel like opening your mic or type in the chat. So just going back, things that we would do over and over again and spend time with it. The whole thing, the whole probability has an area of 1. And usually we will be dealing with just one side of it, or which is 0.5 and 0.5 here. Then we transform it to the Z, we do a Z transformation, and then we can find the values in our table, okay? So let's go for the next one. Between 2 and 3. So we still know that our mu is 3.38, our sigma is 0.42, but look how I draw this probability between 2. So x has to be bigger than 2 and smaller than 3. So smaller than 2, bigger than 2 will be, 2 is definitely to the left side here in our distribution, and 3 is also to the left side of our distribution, but it's a little bit closer to the center, to the mean. So let me click. 3 is there. We knew it already. We saw it before. And now 2. This is the area we want between 2 and 3. Okay. Now let's put it down to the Z table. Let's do the Z transformation, same steps. Now, but I moved already. I moved already the values we calculated before, because we know this side of between 0.38 and 3. Oh, sorry, 3.38 and 3. We know it's 0.3159. We also know that the Z transformation of 3 ends up with a minus 0.90. But now we need to do the same thing for 2. So I'll click once again here, Z transformation, and look how it transforms the ZX that was here. Let me click and look, use the spotlight thing. Hope it works. The X that we had here becomes the Z, and the little numbers we had here, 2 and 3, becomes this X minus mu over sigma. Once again here, quite repetitive, but it's good to do it over and over until it's automatic for us. So we know that this number is going to be minus 0.90. So how much is is this number going to be? Let's go back to the mouse. Let's put it here. 2 minus 3.38 equals minus 1.38. Then we divide it by 0.42, which is our sigma or standard deviation, equals minus 328,571. Usually, because we are only using 2 decimal places, you can see this is bigger than 5 or 0.5, whatever is easier for you to think. So we're probably moving this one up. So instead of 8, we will be minus 3.29. And remember not to be afraid of the negative values. So when we're working to the left side of the mean, we usually have a negative. We will have a negative value there. Let me click once again. So minus 3.29 and minus 0.9. Now, let's go to our table. Once again, I'll ask your participation. Now you guys know how to find those values. We already knew how much was the 0.9, but could you please find the 2.39? Let me go back. Sorry, 3.29. Sorry, got me wrong in that. 3.29. Let me put 3.29 in the chat before I say that wrong again, or if you go, in case you guys forget. Can I please have the value? I can see some there already. Really good. Nice, nice. Guys, I know like you're probably seeing there already. Make sure you're making an attempt for the ones that haven't put in chat yet, and see if you got it right or wrong, and see what was wrong. And it's a good way, because we will be using it a lot in the course, this table. So yeah, give it a go. So let's go. We minus 3.29, so 3.2. We have this guy here, but he ends with a 9. So we're probably looking at this column to have the second decimal there. So 3.2 going all the way, 0.9. Then we find this value here that Noah and Harry posted. Good job, guys. 0.4995. So let's bring this back. There we go. So probably, look at that. This is the distance between 0 and minus 3.29 in the standard normal distribution, or in back to our normal. This is the distance. Sorry, back to our distribution of our thing before the transformation is the distance between 2 and 3.38. Probably feel free to criticize my drawing, but since it's 0.4995, probably this little thing here, well, nope, that's not what I wanted. Should be much more to the left, because the area is almost 0.5. It's almost the whole area here. So I left a little bit too much there. I thought it would be nicer drawing this way, but probably you would think that this little bar, it's much closer to the left. Okay. So how to calculate? Look at that. Now we have both of them. We just need to find the area. And area is a good between the difference of both, right? The area that it's painted in green here. So the whole area is 0.4995. And this little space is 0.3159. So what we're looking at is just a subtraction. 0.4995 minus 3159, 0.1836. Pay attention that we subtracted, and depending on what we're doing, we might be adding. In this case, always the area we have in these tables is the distance between the mean and the value. That's why we subtracted, right? So here, the 0.4, I know it's a little bit repetitive. I'll apologize for that, but this is one distance. This is the other distance. So to find this little guy here, we need to make a subtraction. Okay. Any question on this one? I know I'm going a little bit slow, but yeah, just want to make sure everybody's getting it. I have the chat open here to the left. If you guys have anything, let me know. Let's go for the next one. Now, between 3 and 4, and now you see the difference. Look at what we're trying to do. We have a 3 here, but now we have 4, which is bigger than our mean 3.38. So it's to the right. The thing is, remember, because it measures the distance between the mean and our z value will be here and here. So instead of subtracting, we're probably adding, right? So let's go. Let's do the same z transformation. We're spending a lot of time in this exercise, but I think it's important. Z transformation, the same thing we did before. Look here, look at here. Look, it's not very different than between 2 and 3. It's not very different than between 3 and 4. But now we were on the other side of the z table. We got a 0.90 for the 3, which is the same that we had before. And now we have a 1.48, positive number, because now we're working on the right side, right-hand side of our z. Okay, let's go. Now for the 4, can we once again please find the the value. Let me go again. Let me put it there. 1.48. Excellent. Come on, guys. Maybe a few more. Make your make your attempt looking at the table and finding the value. Make sure that you're able to do it. I'm sure by now you guys are already getting. Excellent. Thank you. I will ask you guys also another detail. In order to have your exact answer for CMLs and LBRTs, because they're very particular with their decimal, try to use all the 4 decimal places for the probabilities. That will be kind of a standard that we use. So don't do 3, 2, or 1. Use all the 4. Okay, so let's go. That's how we're going to find. Let me do my little thing. 1.48, where we go in this line, and then in this column. And here it is. Good job, Harry, Noah, and Junction, who found the right value there. Let me close. Let's go. There we go. I also noted you noticed that I put it the other one over there too. And look how it ends up being. We have the area 0.3159. And we have the other area in here, 0.4306. Let me just call the attention for a few things. We're talking about area. So it is a positive thing. There's no negative area, right? We're talking about 0.3159. It's this area in here. 0.4306 is this area in here. Sometimes you might see, we're talking about the distance between here and here, but it's the area, okay? The distance would be more the Z value, but forget about it. It's this guy here. And so there's no negative to this. We're adding both, and we're getting 0.7465. If you guys have any question, just pop it in chat or open your mic. Otherwise, I'll move to the next one. So next, which will be more than 350, we have our average, our mean on 3.38. So we know that 350 will be to the right. And let's go. Look at that. We're looking for more than. So it will be even more to the right than the 3.5. Okay. I will click once again, that same stuff. Z transformation. 3.5 minus 3.38 gives a very small number, divided by 0.42, and we have 0.29. Just one last quick, 0.29 is what we're talking about. If you guys don't mind, like having a little bit of attempt on how to find it. Quick thing. Yes, perfect. Thank you. So, where is my pen? Lost my pen. Oh, sorry. So coming from 2 and then 9, 11, 41. Thank you, Noah. Let me go with that. So we know the thing is, this is the distance we have from here until here. So what we're going to do is to subtract this distance for the whole 0.5. And then we have the rest, which is this part here, 0.3859. Right? So this is it for question 1. Any question before we go to question 2? Either chat or mic. I will close. I'll move back to the mouse. All right. Oh, also, because I also have a poll for this one. So let me open the poll. Question 2, launch. And I'll give you probably 2 to 3 minutes while I'm reading the question. So a bank manager knows from past experience, get the advice that home loan applications requests follow a normal distribution. History has shown the home loan application mean is $70,000 and standard deviation $20,000. A home loan application has just been received by the bank managers. Okay, so what is the probability the amount request is 80,000 or more? Before I go there, let's go to our poll. Our poll is, what symbol would you give to the $20,000? Then what symbol would you give to the value $70,000? And what is our variable of interest? I have 9 answers up to now. Let's read it again to give you a little bit more time. So our bank managers knows from past experience, home loan application requests follow a normal distribution. History has shown the home loan application mean is $70,000 and standard deviation is $20,000. All right. So the question goes, a home loan application has just been received by the bank manager. And you'll see in the questions, we're like, what is the probability that the amount requested? And then the B, amount requested. And C, probability that the loan application is within $30,000 either side of the mean. So what is our variable of interest? What are they talking about? What do they want to know? And what should we do with the 70,000 and 20,000? I have now, I'll give more 5 seconds. I have 16 answers. 17. All right, that's the same amount we have for the first one. I will end the poll and share the results. So first, the 20,000, I just changed the order here just to see if I added a little bit more trick, but I couldn't trick you guys. The 20,000 was the standard deviation and it's sigma. Good job. You guys, 9 out of 17 got it right, more than half. The 70 is the mean. We're still talking about population, right? Let me bring this thing back there. And our variable of interest is the amount, home loan application amount. So good job, 10 out of 17 got it right. Same for the mu, 9 out of 17. Very good job. I'll stop sharing. And here are the hints. So from past experience or history has shown usually indicates we're talking about population. Mean is 70, mu, and standard deviation is 20, sigma. Very good job. Let's keep going. So we have the values and the question starts with, in A, what is the probability that the amount requested is 80,000 or more? So let's put a line on 80. You will see I summarized here. I didn't put 80,000, 70,000 just because it will be too large, but it's 70,000 is the mean, 80,000 is where we are. So to the right, because it's bigger, right? Let's go. Let's do our standard normal distribution. So our Z transformation. Z here. X is our 80,000. We subtract and remove 70,000 divided by 20,000. And we get a 0.5. It's basically 10,000 divided by 20, 0.5, right? This is how it looks like in our distribution. And it's very important during the exercise, try to draw it and put the center, which is the mean, in the picture. So you're still working. You can see things happening. So we're transforming the 70 to 0, and the 80 is becoming 0.5 because one whole standard deviation would be a jump of 20. So a jump of 10, it's 10,000. It's just half of it. Okay, hope that makes sense. We're looking for 0.50. So can I get here the value, the amount? Ooh, chat, 0.50. I'm happy with the first one that gets the value, but I hope you guys are all making your attempt. Very good. Thank you very much. Excellent. So let's annotate here, 0.50 would be in this line and ends with a 0. So this column, which is 1915, 0.1915. Excellent. Close. Let's go. There we go. So now we know the area, but we know this area here. Basically, as we did before, 0.5 is the whole thing minus this amount will give us what we want. All right, 0.5, 0.3085. Luckily, this question is not really different from our previous one, so it's a little bit repetitive. Hope you guys really know how to do at this point. Oh, let me close the chat. Next one. What is the probability, the amount? Oops, I think I'll just keep it like that. The probability, the amount requested is more than 80,000. And what is the difference? Look, what is the probability the amount requested is 80,000 or more? So this one includes 80,000. Probability that it is or more. And what is the probability that the amount requested is more than 80,000? So this one doesn't include 80,000, right? How do we see this difference in our notation? Look, I have written as 80,000 or more, so bigger or equal, and just more than 80,000. That's what it means. And I'll click. So this one is inclusive, this one is exclusive, and the difference of them. So if you get this one and subtract this one, then we have just the probability that X is exactly equals 80,000. And can you guys pop on chat? What is that probability? Excellent, Harry. That great answer there. Can you now? What is the probability that the X is exactly equal 80,000? And I will put the answer for this guy here. Yes, good job. Why is that so? If you want to type down a quick question, a quick answer, doesn't need to be super complicated. I think the trick here, exactly, no, yeah, it's right. You're right. The trick here is that we're always talking about an area. The probability or the proportion, it's in area. So this distance, where is it? This distance here, sorry, this area is calculated. It's the from this drawing. So it's this whole thing. Exactly. Yeah. If you're talking about, when we're talking about just 80, we're talking about just one line. And this line has 0 with it. It has probably has a height, but with 0 here means the probability will be 0 times the height, which is 0. And this is a property for continuous distributions. The normal distribution is one of the continuous distributions. So the probability of one value to be exactly there is 0. It doesn't exist. We're always talking about a distance between 2 points there. So the area between 70 and 80 for that one, or in our standard from 0 and 0.5. Okay, so that's why this one will be 0. Remember, it's an area. If it was a discrete probability like the binomial, then yes, then we have a probability for a single value. So, and because normal is continuous, perfect, equals to 0. So that solves A. Basically, let me go back here. If it's not clear for you guys, the value will be the same, 0.30 and 85, because adding or subtracting the 80,000 ends up with the same. So question B, what is the probability the amount requested is between 65,000 and 80,000? So let's have a look here. If 70 is our center, is our mean, then 65 is to the left, 80,000 is to the right, right? Same thing here. In terms of the between, in the end, we can talk about, are these values inclusive? If it's between here, it's between these two values. Let me draw. We have a line here for 65, one line for 80. Then we would do a Z transformation, as we usually do. You see here, we got a minus 0.25. It's very nice to work with round standard deviations because you get round numbers, and a 0 plus 0.50 here. Since the standard deviation is 20, so 10 divided by 20 is 0.5, and 5,000 divided by 20,000, in this case minus 5,000, it's minus 0.25, right? Let's go. We have the 0.5 already, if I'm not mistaken. So let's find the 0.25 in here. Can someone please indicate in the chat how much it is? Zero point 0.25. That's the number we're looking for. Excellent. Thank you very much. Thank you, guys. So pretty much 0.20 and 5 ends up with this guy. Very good job. All right. Let's go back to the mouse. There we go. And we also had the 0.5 already. So we will replace our values in that. And then we have 0.2902 for the answer for the second one. Why are we adding again? So our measure, like our Z, the area that it gives us is from the center to the Z value, and then from the center to the Z value. So these areas are not on top of each other. They're not on the same side of our distribution. So we add them. Perfect. Let me know if you guys have any question. Just a little bit, I'm paying attention to the time. I think we're all right. We're just a little bit over time, but the next ones will be a little bit quicker, so we should be fine. So question C, what is the probability? Oh, I didn't discuss the values inclusive, did I? I should have been. Oh, sorry. So if it's between 65, are they inclusive or this value is inclusive? The answer for this one is that it doesn't really matter because we're talking about a continuous distribution. I ended up drawing. I understand that between is not inclusive. Yeah, no problem. I just got a message here, but no problem. So we're discussing in between two values. So I understand that it's not included. So I don't consider it inclusive, but it doesn't matter for the normal distribution. Just go back to B, right? Let's go to C. What is the probability that the loan application is within 30,000 either side of the mean? So within 30,000 either side, we have 30, sorry, not 13, 30 to the right or 30 to the left. How do we do that? Let me click once again. We just put it in our probability. So 70 minus 30,000 and 70 plus 30. And let me one more here. So basically the probability of X being between 40,000 and 100,000, right? That's what we're looking for. Then Z transformation, all the things in here, minus 1.5 plus 1.5. I will go straight with this one. I won't ask you guys. Sorry for that. If you're having too much fun. 0.5. And it's a 0 in the end. So this is the number we're looking for. 0.4332. Right? Just put it there. So once again, one to the left, one to the right of the mean. We will add both values and get a 0.8664. Any question for question 2? Ooh. Chat. Okay. Oh, good. Let's go for question 3 then. Two workers. Oh, let me see. State variables in units. I do have a poll, so let's do the next poll. Let's go. So two workers are subject to work-related injuries. One disorder caused by strains to the hands and wrists is called carpal tunnel syndrome, and is estimated to cost employers and insurers an average of $30,000 per injured worker. Suppose these costs are normally distributed. First, state the variable and its units. So here, for people watching it later, we have a poll. Let me see, let me click once. And I'm asking, what symbol should we give to the value $30,000? It says N mu X bar sigma S. What is the variable of interest? And the options are two workers, normal distribution, carpal tunnel syndrome, work-related injuries, and cost to employer and insurers. And third, what are the units of our variable of interest? Is it workers or dollars or hours or years or injuries? Okay. Let's go. I will give you another 30 seconds. I have 11 answers up to now. I think by now you guys dominate. I think one of the tricks in this course is to read the question and know how to interpret, know where to put the values, and then you just place in the formula and things work beautifully. Let me go there again. Maybe another 15 seconds. I have 19 answers now. Very good, excellent. It means we're 24, so just missing 4 people. 5 seconds. And that's it. I will end and share results. So the 30,000 we have is an average. It's saying in here, right? So it's probably a mu. Why? Because this, once again, we're talking about population. So you see, it's estimated the cost of employees. It's more like historical data. It's not like a sample that we collected. It's something that we know already in the past. So usually we're talking about a population parameter. So it's mu. Very good job. 10 out of 19 got it right. What is our variable of interest? This was quite a split here. I know, I think the question was a little bit harder than I expected, but we're told what we want to know. Suppose the costs are normally distributed. So we're talking about costs for this one, not the, it makes sense to say it's the two workers. It makes sense it's an injury. And it is normally distributed, but our variable of interest is how much it costs. And then it makes it easier because you guys got really correct for the third one. What are the units of our variables of interest? And it's dollars. 12 out of 19 of you got it right. So yeah, this would be an advice for the second one. We'll stop sharing the results. Basically, this is the answer for part 1 of A. And if you have any question, please send a chat or open your mic. But now we're moved to the second one. If, and it's more tricky now because we're doing it the opposite way, opposite direction. If 90.8% of costs are more than 7,000, find the value of the standard deviation to the nearest dollar. So no cent, nearest dollar. Let's round it to integer numbers for dollars. Let me click. Let me see how much I spoil. What do we know? Look at that. Where do I put my 7,000? Given the average is 30,000, so it's to the left. I put it very far away there, but it was kind of a random choice. How do I know it's very far away? And it's probably even further. They said that more than 7,000 represents 90.8% of the probability, right? So it's 90.8% is like 0.908. Since we know that the whole thing we have here, it's one, the whole area. If you consider this whole area, then 0.98 should be most of it. So maybe a little tick more here. I don't know. I think this is about 10%, which is about what's missing there. I don't know. That's where I thought would make sense. All right, and we want to know our sigma, our standard distribution. So how do we do it? The same thing, same strategy, but going the other way around. I'll click a little bit more. Now let's do a Z transformation. So P of Z. Here we can put our 7,000. Mu, we can put our 30,000. 30,000 coming from here. For the Z distribution, and to look in our table, you will notice that we don't have values past 0.5. So we're always looking at just one side of our distribution. So it's either the left side or the negative numbers or the right side, the positive ones. Since 7,000 is less than the average, we're probably looking for a negative value for our Z value, right? We know that the whole thing is 0.908. And we also know that this is 0.5. Therefore, this one would be the difference. Let me see. I hope my next slide has the difference. Amazing. So, yep, you just subtract one from the other, and we have 0.48. Look here how we have things. But I know, looking in our table, how to find the other side of this guy here. 0.408. Let's see. Can you guys help me find the Z value now based on the area or the probability that we had? 0. Excellent. I have one answer there already. What we're doing here, we're looking to the closest number. I think we might have 0. Let me type it down. 408. That's what we're looking in our table. So let's go. You can literally just look for the number, because now we're doing the opposite. 0.408, you will be going, okay, it's growing this direction, right? So you're coming, okay, 0.408, and you find that the closest value is this one, and these other guys are considerably far away. So it's not kind of halfway through, it's very close to, it's very close to this one. So how do I find? This is the answer. So 1.33, as Harry posted before. Okay, let's go. 133. All right. So now I know. Remember, this is the area in the standard normal distribution, the Z. So I know that this area is equals to the probability that Z is bigger than minus 133. So this is important because the pluses and minuses is something that can be tricky during the exercises. We know it's a minus. We found 1.33 positive, but we know it's a minus because it's on the left side. And we know that this area is always the distance between the mean and the Z value. So Z, the probability that Z is bigger than minus 133 until the mean, right? Because we know if you consider the whole thing would be this whole thing, but that's not what we're looking at. when we look at the Z table, is from here until here. So Z is bigger than minus 133. Makes sense? Hope. Can I get, just checking if everybody's awake. Can I get a few thumbs up here? Ooh. Let's see. Do you guys remember how to do it on Zoom? 1, 2, 3, 4, 5. Excellent. Thank you. Hope everybody's there. Paying attention. Excellent. Thank you so much. Let's see. How do we know? How do we do from here? Look, we have a BZ bigger than something, and then we had, or the only unknown variable is the sigma, and then we have B of Z bigger than minus 1.33, and we know that these are equal. So this value is probably this amount. It's probably the same as this. So we can make this equal to this. Exactly. Perfect. How do we solve that? Minus 23,000, which is 7,000, minus 30,000 divided by sigma is equal to minus 1.33. Put in a calculator, move things a little bit around, and you will find the sigma is equals to 17,293.23. All right. And that's the answer for our question, part A of question 3. Any question, please feel free to send it on chat or open your mic, but I'll get going. It's 5:06 now. Get going with the next one, okay? You will see there's a little mistake there. I thought, okay, I'll leave. This is B, but it will be showing A in your thing there. Just a small remark. Now, suppose the mean value of the carpal tunnel injuries is unknown. So the 30 that we had before doesn't exist anymore. So mu is a question mark. But the standard deviation is 9,000. And now we know that the sigma, or the standard deviation, is 9,000. Find the probability that costs are within 3,000 of the mean. So let me click once. Let's see what I have in the next slide. Take this out of the screen. We don't know mu. We know sigma is 9,000. And I want to say that our mu, the mean, the center, sorry, I want the probability that it's between 3,000 within. It's within 3,000. So 3,000 to the left or 3,000 to the right. Okay. So I put here mu minus 3,000 and mu plus 3,000. Not super tricky, I would say, right? Oh, I think I have a typo here. This is supposed to be plus. Sorry for that. Mouse. So let's go. Let's do a Z transformation. Look at what happens. When we do the Z transformation, our X is this whole thing here. Look, when you put it there, and this whole thing here, which is supposed to be a plus, it is a plus here. Fine, I fix it. So then you will see that actually the mean doesn't matter. Mu, I mean, doesn't matter for our Z transformation because it is 0 in the end, right? So it will disappear here, and we will get minus 3,000 divided by 9,000. It's minus 0.33, and then 3,000 divided by 9,000 is plus 0.33. Now, ask your help. We're going to look at our standard normal distribution table. Can you please help me find? Yeah, excellent. 0.33. Good job, Harry. So if we go to 0.3 and then 0.03, we find 0.1293. Good job, thank you. And me, Let's go. All right, so we have, once again, we have the area, and we're talking about two sides of the main. So it's the area from here to here, and then the area from here to here. So these values will be added, and we get a 0.2586. And that's the answer for the first part of A. I know it's a little bit more, a little bit trickier, right? But you know, I think you guys can manage. And we have in our tutor notes, it's saying like this type of exercise, we can tell you guys, it might be on your CML. So have a good look at how it's done, and spend some time, pay attention to how it's written so you can get it right, okay? If you have any questions, send in the chat. I will move to the second part of it. So how much would the average cost be if 87.8% of the costs were less than 33,000? Look, a little bit of flips around. We don't know the mean, or the average. That's what we're looking for. But we know, as we did before, that 87.8% are less than 33,000. So the probability of X being smaller than 33,000 is equals to 87.8%, which is 0.878. Once again, we will do the same thing we did before. 87%, it's a high number. It's more than 0.5. So we're talking about, let me try to use the rationale here on how to draw. This is more than 0.5. And we want X to be smaller than a number. So this number is probably to the right of our distribution, because I'm going to paint almost 90%, 87% of it. And this number has to be bigger than this 87%, right? This is a little bit what we're doing. Does that make sense? I hope this is making sense. Okay, let's go. I'll click and we have the drawing. So 33,000 is there, 87% draw of that. This is 0.5 part of it, and this is the extra. Would it be 0.378? Let me click. 378, when we make the Z transformation, will be just this part over here. It's the 378. And look what we have. So 33,000, our X minus the mu that we don't know, divided by the standard deviation 9,000 that we know. Okay. And we're looking for 0.378. Let me open chat. Oops, mouse click. Let's go to the table 378. Let's see, I'm happy with just one. And a little bit of extra difficulty here. And it's a case you will fall sometimes, probably in a CML too, I would say. At least one exercise must ask you to think a little bit more on it. And I'll give you a hand. So when we're looking, once again, it goes this direction, then we go 378. I get 377 in here, and then I get 379 in there, and just a 0 in the end and a 0. So 378 is exactly in the middle. When it's exactly in the middle, and just in that situation, we will get an average. So we have a 1.1, but I have 6 and 7 for the second decimal place. So between 6 and 7 is 0.065, right? I will not use this anymore, neither this. I will type it for you. So 1.16. Let's say I did a plus 1.17. And these guys added, divided by 2, drew 1.165. And it only happens when the probability you're looking for is exactly in the middle. Okay, that is it. Clear? 1.165. Let's do that. You will see how I did it. A little bit of a mix. So here it is. We know that the probability of Z being smaller than 1.165, and let's interpret it together. We knew that we have this 33 here, right? Can you see what I'm circulating and doing? Because it's not drawn for me. Basically, it's the area between this number, the distance. It's not what I wanted. Sorry. Okay, if it's not working that way, I will do it this way. We have this one, and we're looking for this area, so we can use straight our 0.378 here. 378, and it gives us, we come to this number, so we know that like this whole value is the same as this little one. So we just put it here, flip things around. So the 9,000 goes there, multiply the 1.167, 165, and then the minus 33 moves to the other side, is also negative, whole negative number. Just multiply everything, and you have a mu equals to 22,515. And that's it. Any question? That's the last part of question 3. Let me open chat to see if I'm missing something. Amazing. All right. And going to our last question. Let me see. I'm not sure if I have a poll right away. No, I don't. Let's go. So the Kemp family has twins, Rob and Rachel, who have graduated from university and are now each earning $50,000 per year. So Rob and Rachel are earning the same amount. Rachel works in the retail industry, where the mean salary for executives is less than, with less than 5 years of experience, is $35,000, with a standard deviation of 8,000. Rob is an engineer, and the mean salary for engineers with less than 5 years experience is 60,000, with a standard deviation of 5,000. Compute the Z value of Rob and Rachel and comment on your findings. This is an easier exercise, and it's more for us to get a little bit more of a feeling what the Z value is talking about. So I put together the information that we have there. So Rachel earns 50,000. This is our X. The mu for her field of work is 35,000. The mean, the average, and the standard deviation sigma is 8,000. And Rob is 50,000, same, but it's a 60,000 average, and 5,000 standard deviation. And then I have a poll. At this point, let me share with you, launch. And there it is. Pretty much the poll is, I'm sending you, has a few values, but I think I already give you a little bit of advice here in the screen on how to reach the value you're looking for. The poll, for people watching it later, the poll is asking, where's the poll? Rachel's Z value and Rob's Z value. I'll give you, I already have 3 answers. Give you guys a little bit of time to calculate. But I will discuss a little bit. So Cam's family has twins, Rob and Rachel, who have graduated from university and now each earning 50,000. So we know salaries are the same, 50,000. This is our X. Now we will talk about the mean and standard deviation for each of the fields. Look at Rachel. Rachel earns 50,000, but the average in her field is 35. So 35 is here. A little bit of annotating there. 35 is here, but she earns 50. So her salary is to the right of the mean. But Rob earns the same 50. But look, when you are in a distribution where 60 is the mean, a 50 would sit to the left, right? The standard deviation is 8 for Rachel and is 5 for Rob. What is the standard deviation? And what is the Z value in the end? When we do a Z transformation, the Z value is telling you how many standard deviations it goes to the right or how many goes to the left. So we know already, and this might be a little bit of, let me see how many people answered the poll. I have 15 answers. We have potential for another 17 answers. So another 5 people, just missing 5. And you guys are getting the little bit of advice in the end. So we know that this Z should be a positive number because Rachel has a bigger X than the mean, right? And this Z should be a negative number because Rob has an X smaller than 6. And let's go. I'll end the poll. Let me see how many answers. 18. Excellent. Thank you for your answers. End poll. Share results. And look at what we found. So Rachel 1.875. We had 14 out of 18. Amazing job, guys. This is correct. And for Rob's, it's a minus 2.00. And if I click here, you guys are absolutely correct. 1.88, I rounded it just to 2 decimal places, and minus 2 for Rob. And when did they ask us to comment on your findings? This means that pretty much Rachel's earning well in her field. She's earning above the average. You'll see I transformed the previous values to a Z1. And Rob is earning not so well in his field because he's 2 standard deviations below the mean. Rachel is 1.88 or 1.875 standard deviations above the mean. So just to read it in a different way, the mean in Rachel's field is 35,000. The standard deviation is 8,000. 1.875 times 8,000. And I'll show you in a calculator. I'll make the thing the other way around. 875 times 8,000. 15,000 plus the average 50,000, which is what Rachel receives. Works like magic. And the other way around, let's do the same thing for Rob. Look at Rob, pay attention to the minus. So minus 2 standard deviations times how much is the standard deviation? Equals minus 10,000 plus the mean for the field, 60,000, 50,000. It works. It's perfect. So that's a little bit of interpretation, and I'm trying to go like one way or the other way around, like back and forward. So it becomes a little bit more clear what we're doing here. You know that the whole thing has an area of 1, and now you know left and right there, negative and positive. And this is what we did for today. This was the answer for question 4. So at the end of the tutorial, what we know. So describe the characteristics of the normal distribution, standardized normal distribution. I usually call standard normal distribution, but standardized, it's not too different. So we know it's symmetric. It's identical to both sides. Well, you know that the whole probability is 1, right? If you add the area of the whole thing. And when it's standard or standardized, we know that the center is 0, and we know that the standard deviation, is 1. So each standard deviation, its space, it would be 1. So interpret and use the standardized normal distribution tables. We did it a lot. We did it for every exercise, and compute set scores and associated probabilities. Good job, guys. I will stop the recording here. Good luck. Don't forget about your LBRT. People watching it later. Yeah, you have until tomorrow, Wednesday, 4 p.m. And the second attempt will be between Thursday and Friday. Thank you for attending it, and have a good one.